Good afternoon, everybody, and welcome to my presentation. My today's presentation topic is monitoring chicken embryo development by visible light transmission spectroscopy to predict chick hatching time. One-day-old chick is very important for poultry farmer, and the overall success in poultry production depends on the quality of chick they use. But the uniformity in the quality of a batch of chicks depends on the spread of hatch window. And in actual case, hatch window is spread from 24 to 48 hours, which causes early and late hatch of chick. And at the time of chick collection, it is observed that the earlier hatch chicks show the sign of dehydration, and when it chick transferred to the poultry farm, shows the high mortality rate and the poor growth rate. And the late hatching chicks still wet and immature, and also shows the high mortality rate in the feed in the poultry farm. So it is important to control the hatch window. To control the hatch window, the poultry hatchery practice different methods, and among these, they allow these chicks to hatch around 24 hours, and after this time, they discard the unhatched chick. Still, there is some chick they can hatch, but they discard from the lot. That causes reduce the hatchability and causes economical loss. And some poultry hatchery practice, they increase the temperature of incubation air, and also sometimes they increase the carbon dioxide level in hatchery, which stimulate the hatching time of chicks, but these are detrimental. When the carbon dioxide concentration increase, this start the anaerobic metabolism, which causes the chick lethargic and exhausted. So a short hatch window is very beneficial for the poultry hatchery. So a new hatch window controlling technique is needed, which can produce best quality chicks and also maximize the hatchability. Now, how to monitor blood in hatching egg? Hemoglobin is the detected pigment in blood, and the 577 nanometer suitable absorption band is useful for blood detection, and the optical the transmission spectrum of transmitted light can be used to detect blood in the intake egg, because optical transmission is used to measure the internal quality of different biological products. So this can be used to monitor the change in blood content in intake egg. And also the visible light transmission spectroscopy commercially used to detect blood in consumption egg. So we can use the similar principle to detect blood in incubating egg. And our research goal to develop a hatching time prediction model based on the information of blood content of incubating egg at early stage of incubation. This is the materials and devices, and we use ROS 308 parental breed, 42 weeks age, and we use Hamamatsu C747336 spectrometer to measure the spectral transmission. And this is the detailed procedure, and our experiment contains 3 different experiments. At first, incubation for facilities the development of embryo, then spectral measurement, and finally from incubation day 19 we monitor for record the hatching time. And this is the spectral measurement setup. we use this setup in Naval company, and the optical measurement, transmission measurement procedure is everyday measurement. At first we measure the transmission spectrum of a reference material Teflon block, and then we measure the transmission spectrum of chicken egg, and then the raw transmission spectrum was transferred to a proportional transmission as like this. And during this experiment we expose the exposure time for each measurement is 20 millisecond, and the resultant spectrum is an average of 3 consecutive measurements. And determination of hatching time, we monitor hatching eggs from incubation day 19 to until all chicks hatch, and during monitoring we captured image every 5 minutes intervals, and from the captured image we detect the emergence of time of emergence of chick, and from the time of emergence of chicks and the time of setting egg for incubation we calculate the hatching time. And this is the two consecutive image for a one hatching chick, and from this we calculate the hatching time for the respective chick. And this is the relationship between the T577 and T625 ratio and the hatching time, and we found that this correlation is not so strong enough, and is not strong enough. And I found other literature and found that the hatching time of chicks depends on many factors such as parental breed and age, egg size, egg handling, storage time, incubation condition, like this. In our experiment we consider all other factors except the egg size, and I also found one previous report that the large size egg needs more time to hatch than the medium and small size egg. So in our experiment, next experiment we will consider the size of the egg. In conclusion, developing chicken embryo affects the ratio of optical transmission at 577 and 625 nanometer band during incubation, and the T577 and T625 ratio is promising to predict hatching time, but need further study to develop a more efficient hatching time prediction model. Thanks to you for attention.
Question? Go on.
Why is marker direction to be the
At first I used the Naval company setup. I did not think about that, but in the next experiment I will change the position orientation of egg, because I found some literature when incubation time increase, the air cell size gradually increase, and I think this may affect transmission. So in the next experiment yes. Sorry, I make mistake there. I will change like this.
How about the distance? You decide to have some distance between your optical fiber with the samples. How you decide the distance in your next experiment between the optical fiber and the samples? How you decide?
Still I did not decide how much distance we will keep. We will make one trial here and then we decide this distance between the optical fiber and light source.
How about the previous?
Mm.
In the last experiment?
Last experiment, we also did not think about what actually happening. We just I just use their system.
Yes, that's why you can ask what is the system. I mean, design of experiments will affect your result. So it's better to design best experimental setup. Depend on your purpose.
If we keep this and this distance same, but X size is not the same. X size is vary. So in the next experiment I have done, I will fix this to distance, keep constant.
For example, in food is already established. They don't keep the fixed distance, but they have to make sure that your optical fiber attached to the samples. In the fruit measuring system. So you know the fruits also different, sometimes different shape, different, but they have a size, but they have to make sure that the optical fiber attached to the
Surface.
But I'm not sure with your egg, so I think you have to search some how
Okay, I will fix this one. But last time when we do this experiment, this exercise was not similar. And when we open and fix this, some shell of the egg was broken. So this time I have a plan. I will keep this distance fixed and make some space so that the shell of the egg may not broken. So I have planned to fix here, to put it, maybe there I will keep some clearance here. Otherwise, because of different in size and shape, shell may broken.
How big the fiber?
1 millimeter.
Diameter?
Yes, diameter 1 millimeter.
For example, if in fruit, usually not enough one point. So that's why 1 or 2 points. Sometimes they investigate the influence of several points and then position. For example, 1, 2, 3, 4, and then they make some subtraction, summation, and then they try to find the best way how to collect the good spectral information of your samples. I'm not sure if only 1 is enough or not. So that's why in the
Okay, I will think about this.
For example, in the fruit, sometimes because the fiber is not so deep penetrate, so that's why the information of this side may be different with this side, or with this side, or with this. That's why in the fruit usually we rotate some, and then we measure some, not only one point, so at least row of 3 point or 4 point, and then make some process to evaluate or some. Yeah, of course, one is faster, but I'm not sure it's enough or not to collect your information.
Okay, I am also thinking about if I put measure for one side, my blood part is in another direction. So maybe 2 or 3 point measurement may give the good result.
That's why design of experiment is important. You make clear better.
Here, it is not clear where is blood. This point or this point or this point. It is not sure. So I have a plan. I will measure 2 or 3 times that. I put like this and change orientation like this.
You may collect some photo, right? Some cover something with optical fiber.
Yes,
Just,
cover.
You have cover.
Yes, black cover.
Black cover. But not so much correct.
We just put cover it like this.
So, not all. Just a point or some area, specific area would be correct.
Why don't you close all of your egg?
We pass light from the bottom. We cover all the system with black cloth, and we also cover this fiber, optical fiber, with another cap to this to eliminate the effect of this light that pass to the outside of this shell.
You don't think about the integral sphere.
I read another paper. They use collimating lens here. Collimating lens. And I also talked with Fujioka Sensei that I want to set collimating lens here. Then Fujioka Sensei told, you no need to think about this, just this here, the average of this spectrum will be recorded here.
You are going to use the lens, that's right.
No, at first I was discussing with Fujioka Sensei. Then Sensei told,
now you reach that way.
Yes, I do this.
You may discuss more.
Maybe.
It's okay?
The Lexus. What kind of Lexus?
Halogen lamp. Halogen lamp.
Halogen lamp. In short wavelength. Only from which $200 to
what's the color temperature?
Color temperature. I forgot, but I have the instruction. I have a specification.
If you focus on the visible region, maybe 4,000, 5,000, but not so big power, 4,000, 5,000. Or 2,000, 3,000, big power.
I have no enough information.
More discussion later. Okay, I think it's time to stop over. Okay, thank you very much.